Hi guys, this is Naveen again. In my previous video, I have introduced you the concept of statically induced EMF. Okay, in my statically induced EMF, I have already said that my my conductors will be stationary and my magnetic field will be moving with respect to time. My statically induced EMF is the hero of my new concept, that is transformer. Before defining a transformer, we need to understand the basic circuit of my transformer so that our definition would be in an easier or in an easy understandable way. Now, a transformer have a basically two parts. One is the primary part, another is the secondary part. Uh, the easier way to differentiate the primary and secondary part is one, the winding or the part which is connected to the source is called as primary part. The part which is connected to the load is called my secondary part. Now, from this basic idea of my construction or my circuit of my transformer, how we can define transformer is a constant power device. A transformer is also a constant frequency device. It just transfers power from my primary side to my secondary side, or in an easier way, it transfers power from one part of the circuit to another part of the circuit by altering either its voltage or current levels. Based upon the voltage across the primary and secondary windings, my transformer are basically classified as step-up transformer and step-down transformer. And see how we can understand a step-up and step-down transformer. The secondary side voltage of my transformer is greater than my primary side voltage. We could call it as a step-up transformer because my voltage is stepped up. And in order to maintain the constant flux throughout the operation, my secondary current will be less and my primary current will be more. By achieving this, or by doing this, or by arriving at this point, constant power is maintained throughout the operation. In a similar fashion, step-down transformer can be understood as my primary voltage will be greater than my secondary voltage, or vice versa, my secondary current will be more than my primary current. From the definition, we could conclude 2 points. It is a constant power device and a constant frequency device. And another point we need to understand about a transformer is it is a constant flux device. Okay. Now, what makes my transformer constant flux device? The main thing what we have to understand is my transformer is a negative feedback control circuit. Now, this negative feedback control circuit makes my transformer a constant flux device. Now, I'll explain you how my constant flux condition is met. Consider a transformer I have shown here. It is easier to understand. Now, I connect a load to this transformer. Okay. Because of that load, a current I2 flows in this direction. Now, because of the voltage in the primary V1, some current I flows through it, and according to the property of my inductor, some magnetic field will be set up across it. Let it be phi1, and this phi1 links with my secondary windings, and according to Faraday's law, because of the relative time variation, some voltage V2 will be induced in the secondary side, and because of it is connected to the load, secondary current I2 flows through it. And from this thing, I can explain you the directions of my voltages V1 and V2. The voltage V1, okay, which is responsible for my current I1, we could relate them as V is equal to L1 into d I1 by dt, and we all know that the current or the flux will be set up because of my current. Okay, the angle between my voltage and the current or the flux more precisely is 90 degrees, and according to my Faraday's law, the voltage induced in my secondary V2 is because of my flux in the primary circuit, or flux produced to my primary circuit, and this is induced EMF V2 is proportional to my rate of change of the flux linkages, and we also know that according to Lenz's law, the angle between effect and the rate of change of cause is 90 degrees. The angle between V2 and phi1 is 90 degrees. Okay, from these two equations we can conclude that the angle between my primary side voltage and secondary side voltage is 180 degrees. Please keep this in mind. It is 180 degrees because it helps us in drawing all the phasor diagrams associated with my transformer. Okay, now again I am repeating you, the angle between my primary side voltage and secondary side voltage is 180 degrees. From this we can also derive a point that my transformer is my phase shifting circuit. Now, coming back to my original discussion, how constant flux is maintained even when it is in operating conditions. Now, whenever I energize my primary, some current will be set up, some current will be flowing through the windings, and flux will be set up, and let the direction of my flux be in this direction, as it will be set up in that direction only. Let it be phi1. Okay, Now, because of the connection of the load, load current I2 flows through it. According to the property of inductor, even due to my current in the secondary winding, some flux will be set up in my secondary winding, and this setup flux will be opposite to my primary side current. Okay, from the before equations that I have discussed about. Now, as a result of this, because of my opposite development of my flux, which is due to the secondary load current, the resultant flux phi r will be less than my phi 1. As a result of this reduction in my flux, the voltage induced in my primary winding will also reduces, because phi V1 is also proportional to my phi dt. Okay. Now, because of this reduction in my phi r, the induced EMF in my primary also reduces, because V is proportional to d phi by dt. Okay, and because of this reduction in my primary side voltage, there will be a potential difference occurring between these two. That is, my V source side voltage will be greater than my primary voltage. Because of this potential difference, some current starts flowing in my primary circuit, and we also must remember a point that this flow in the current is mainly due to my phi 2, okay, which is developed in the opposite direction. Therefore, the flux set up by my current that is flowing through this flowing because of my phi 2 through my primary circuit will be equal, or will be equal to my phi 2, but in opposite direction, again according to the Lenz law. As a result of this, I could call it as phi 2 dash. Okay, phi 2 dash, that means the current or the flux which is set up due to my load current, which nullifies my load component. That is, this phi 2 dash will nullify my phi 2. As a result, constant flux phi 1 will be maintained whenever load is connected to it. Okay, so from this we can understand that my transformer is a constant flux device whenever a load is connected, even when a load is connected or load is not connected. So the three things that we must keep in mind is a transformer is a constant power device, a constant frequency device, and a negative feedback control circuit, which makes it as a constant flux device. And we all know that, or we can easily observe, or we can easily experience electromechanical energy conversion or some kind of energy conversion in all machines, like in motor from mechanical to electrical to mechanical, and generator mechanical to electrical. But in the case of transformer, externally we cannot experience any kind of energy conversion. But internally, there is an energy conversion that is taking place in my transformer. I could explain this. Now, whenever my primary is energized, my electrical energy will be converting into my magnetic energy. Again, this magnetic energy is again converting into electrical energy. From this, I could conclude it as my transformer is also an electromechanical or electromagnetic energy converting device. Some kind of energy conversion is taking place, but it is taking place internally, not like other machines where energy conversion is taking place externally.